Hi there everyone. This is going to be my first tutorial video using POPs, which are point operators recently released by TouchDesigner in the experimental build. So if you haven't already downloaded that, go to the derivative page and check that out. What we're going to build today is this sort of vector attractor. And it's something that we've likely kind of looked at or built before using other methods, maybe in POPs, maybe in TOPS even, or GLSL. But we're going to use a couple of objects in POPs that make it kind of easy to do this, or at least kind of streamlined. Before I start talking about actually how to build this network, I wanted to quickly show you a page here that's going to be really useful if you actually want to get more into sort of mathematical operations and particularly working with vectors and attraction. So even though this is a resource for processing at P5JS, the book, The Nature of Code, which has an online companion by Daniel Schiffman, has a lot of amazing stuff about how to understand some of the vector motion that we're going to work with. So it goes from what the pointer vectors are, kind of explaining the behind the scenes of how actually a vector works, how to add, subtract, and do all sorts of things that we can do in TouchDesigner, particularly with these mathematical operations that are now available with objects like the math combine and math mix. And what we're going to do essentially today is we're going to take a position and also form an attraction position. We're going to subtract our particle position, so all these dots, from wherever our attractor is. So right now we can see I'm defining my attractor with this noise, and that's where that's moving to. So that position, my attractor here is basically taking away these static points, and that's going to give me a direction. Then I calculate the length of that, normalize, and then I'm using a influence factor from this object that is called a field. So field here allows me to basically create a sort of a transition field where I can set a weight that's going to maybe attract or repulse. So I can play with some of these factors. So I could turn that down and have a different kind of transition, or turn it up. And also, if I turn this down, we're not really going to have any transition here because we're going from 0 to 0. We're not pushing out, but if we can push it up more, we'll have a much bigger effect. It's always hard to speak early in the morning. But basically what we're going to do today is we're going to sort of build this step by step. And I might keep this stuff up to kind of remind myself of actually the logic here, but deleting now and starting from scratch. Okay, so we're going to start out with a grid pop. And you could use anything you like really in terms of a generator. So you could use the point generator or, a sphere, whatever you like. But for me, what I want to do, and I'm just going to bring this out to the end of our chain as well, just so we can see it in this panel. I've set up a panel here, so that means I'm going to bring in a camera viewport. I'm going to do a render, and I'm going to make an out. Also going to texture this with a line. And so that's looking okay. I want to make sure this is actually being read as that camera viewport. And one more thing to do is if I want to actually be able to interact with this in my panel, I'm going to go to the panel comp in camera viewport under camera and hit dot dot. So now I should be able to manipulate that in a 3D space. Something that could be useful. Obviously, you could use a top viewer or a geometry viewer to view this, but for me, I kind of like to set this up fairly early on, and then I can see what's happening, and I can move it around with my mouse. Right now, we just have this 2D plane. And what we want to do is we actually want to have a 3D, kind of more like a box effect. And what's cool about the grid in POPs is we have columns, rows, and slices. So slices are essentially a depth parameter. So we have 20 cells for 20 by 20 columns and rows. And then we have 20 slices, so 20 versions of this. For what we're about to do, I kind of like something that's a little less dense. So I'm going to bring that down to 10 by 10. And now we have a sort of a funky grid. And what's kind of nice about this is maybe previously we'd have used things like the box and then do a subdivide. But with this, it's kind of nice that we have these layers because it gives us maybe some new potential that we can work with. Before we kind of go any further, I'm just going to bring down my line width just so it's not quite so intense. I kind of like that. Okay, that's feeling really good. So we've got our grid, and now what we want to do is we want to create some kind of weight that's going to manipulate it. And field is a really useful option here. So what field allows us to do is it allows us to essentially set some kind of display. So we could do a sphere, we could do a box, a torus, and this is basically going to be something that we output as a weight. So if I put this into a math mix, I can actually apply the weight. And this is something that we're going to sort of maybe get used to as we work with pops a little bit more, is we're going to have all these attributes that we can control. So in this case, our field is looking at the P parameter, which is the points. So it's basically the X, Y, Z position coming out of this grid. If you ever want to look at what's happening inside a pop, you can go to this DAT2 and you can see we have this index here, this data readout. So we have our index, we have all our positions, the normals, and the texture values, or the texture coordinates. So this is something that will allow you to see what actually you can access and kind of make sense of that. But in the case of the math mix here, what we want to do is we want to, in this field here, in the attribute scope, we're applying this process, this weight, right now to our positions. But if you wanted to, you could flip this to normals or textures and create an entirely different effect if that's what you want to do. I'm going to bring down this radius to like 0.4, and let's see what happens if in my math mix I just do something like a simple combination of things here just to see how that field weight works. So I'm going to do A times B. I'm going to take my position value and I'm going to multiply it by weight. And so what we can see here is that weight is being applied by this transition range to our sphere. And so we basically have a multiplication of this kind of like, think about it as like a 0 to 1 kind of thing, like we're moving away from the central of that sphere point. And so if I change that from a sphere to say a box or a torus, we're going to get these different types of effects. And this is obviously kind of not what we're aiming to do today, but you can kind of easily see that just by messing around with some of these math operations, we can do actually some cool things. I wanted to not do that, I want to do this. And yeah, so you can see that there's some really interesting things that we can do by kind of manipulating these points just within a math. And this is already kind of a cool effect. Before we actually start building out our attractor, what I want to do is just add in a way of controlling that. So I'm just going to put in a noise chop. I'm going to go to the common tab, hit time slice, and I'm going to call my channels X, Y, Z. And I'm going to drag these into my field transform, X, Y, and Z. And I'm also just going to turn up this period a little bit so it's not quite so fast. Later on, we're going to automate things like the radius. But let's go back to that sphere as well. And so we can see that the sphere is kind of moving around these positions, and then something's happening there that's offsetting that. This is basically where that sphere will be within our space as it moves around in 3D. And what we can also see here is that we have this result scope here. So when it's italicized, what this means is we're basically feeding the output value as P. But what we can also do is we could create our own result scope output attribute. So I could say fantastic. It's a pretty lame name, but that's what I came up with. So then that's something that could be, right now we're just kind of visualizing this as a geo. But if, for example, we wanted to go and instance something, and I drag this in, fantastic has now been added as a parameter that we can actually use, or as a attribute that we can actually use. So I'm going to move back a little bit. We're going to move that fantastic, and we'll stick with this, and actually we'll just say none because we're not doing any operations yet. So basically what's really cool about POPs is we can do a huge amount of stuff with very few operators. The downside of this is it maybe means we have to think things out a little bit more sort of mathematically and step by step. And this can be sometimes challenging. And so that's kind of why for me I kind of write out some of this stuff and make these little diagrams. And so basically what we can do in the math mix is we can create lots and lots of different operations and go through those operations step by step before sending an output. What we can also do is set up some uniforms, and that's what I want to start out doing. So our uniforms are going to be called strength, and this is going to be the kind of the strength of our attraction. And I'm also going to create a uniform for position, and I'm going to call it a pos, and this is going to be attractor position. I want this to be a float free, so basically like a vector with 3 inputs, x, y, z. And what I'm going to do is I'm going to make this viewer active, and I'm going to drag these into my positions here. So I want my attractor position to basically reflect wherever these things are. And that's going to apply when I go through my my operations here. Okay, so I've got my uniforms of strength and attractor position, and now I want to start making these operations. And we can see we have a lot of actions that we can do here. And basically we're going to go step by step, doing a lot of subtractions, multiplications, and additions. And what's going to be the first thing we create is we're going to create a kind of a direction. And so what we're going to say is a minus b, and we want to take a pos. We can kind of see this happening here. We're getting our direction. So we want to take a pos and subtract p. And we're going to, in our result scope, we're not going to put an emoji. We're going to say AP, and that's going to be attractor position. So that's going to be the first thing, and this gets us this kind of initial value. Moving from there, we want to normalize that value so it's a unit vector or a length of 1. So let's go in, and we can see that this new value, AP, has been created. So in scope A, we'll say AP, and we want to call this direction because this is essentially going to be the pull. This is going to be the direction of where that pull is from. Let's add in a few more things. And we can see why it's maybe important to sort of think this through and go step by step, because obviously as I start adding stuff, let's just do a multiplication here. But as I start adding stuff, we can see more things start appearing. And then we also have all this stuff that's kind of available here too. The attributes that we're creating and have immediate access to, though, are ultimately going to appear in this drop down, and we're not going to have to go into here. So keep that in mind. So what we want to do now is we want to take our direction, and we want to multiply it by our weight. So this is going to take whatever the field weight is, and it's going to multiply that, and that's going to basically scale the direction, and we're going to call this scaled dir. Lots of catchy names. And if you can find a way to do this in less steps, that would also be really cool. And let me know if you do. So another multiplication here. We've got our scaled direction, so it's kind of in a format that we want to use. And now we want to take that direction and we want to multiply it by strength. So we'll take our scaled direction, multiply by strength. And we're nearly there, so we're going to call this force. The final thing we have to do here is we want to add our source position, so the original positions that we're working with, so P, so all of these points, we want to add that to our force. And automatically we can see here that because we put in P, it's resulting in a scope of P. Obviously, if you want to change that, you can go in and do that, but you can write that in too, or you can go from the drop down. But basically, in this instance where you put in something that is a fully formed attribute, unless you want to rename it, it's going to have that often in italics. So you don't actually have to put that in. It's going to assume that we want to output those source positions because that makes sense as an output. So now we have this attractor, and it's basically made with one object. Something else that might be interesting to do is to automate this size. So let's go in and automate that attractor size. So I'm going to go into my noise, common tab, time slice off, and I'm going to say SZ. I'm going to drag this in to my radius. And ultimately, I want this to be an absolute value. I'm not ready for this to be in the negatives yet. I want things to be between or above 0. So I'm just going to wrap that in abs, just so it's going to be an absolute value that doesn't drop below 0. So we can see when it's negative here, it's still going to be positive there. I'll also turn down this period, and you can go ahead and turn up that value and kind of see what happens. So that's kind of one thing that you can do. We can play with this transition range, and that basically softens the effect. We can see here it's quite harsh, but as I play with the transition range, it gets a lot softer, which I really like. And we can also go in and we could play with like how big that transition range could be. So you can add to that. But for now, I'm going to keep it just as 1. You also have these options of like different types. So you could have a linear type or a smooth step or an ease in and ease out. So these are all going to give you slightly different ways of playing with that attractor, which I think is super cool. I'm just going to stick with linear. And a couple more things that we're going to do before we finish up this tutorial, just to make things kind of look cool and nice and give you some ideas on how you might want to sort of post-produce using some pop logic, is what I want to do is I'm going to create a sphere and actually visualize where that sphere is in our scene. So I'm going to create a sphere and I'm going to plug that into a geo. Nice and big. We don't want that. So what I'm going to do is, again, I'm going to take my, let's apply it to the sphere actually. I'm going to take my X, Y, Z positions and apply that to the sphere. And I'm also going to take my noise size, and that's going to be my my scale. Well, that's maybe getting too big there. So let's bring that down to, we want things to maybe be, there we go, a little smaller. And ultimately, I don't particularly want to actually visualize what my sphere, where my sphere is using this method. But what I do want to do is I want to showcase this thing that I really like, that I think is going to be a kind of a hit in terms of the pop world, is this thing called proximity. So I did kind of give people a look at proximity in my other video where I was just doing a first look. And what proximity does is it basically connects things based on proximity to each other. And what we can see here is as that sphere, or as that attractor is displacing some of these particles, they're pushed closer together so we can kind of see these lines starting to appear. And so basically proximity allows us to do a sort of a plexus effect. In this kind of box context, it's not going to be so exciting. So I'm going to show you something else this object can do that's really cool. But yeah, if you're working with like noise and want to connect kind of particles together based on proximity, this is a really easy way you can do that. And this is something that people have kind of been wanting to do in TouchDesigner for a really long time. So what we can actually do is I can take this sphere and plug this into the second input. Right now, we're just looking at this initial source and basically just drawing points together where they kind of intersect. But here, if I bring in my sphere, what's going to happen? Sorry, my computer glitched out there for a second. But basically what happens if I connect this sphere is, so right now we can see that the proximity is sort of drawing these points based on distance. If I connect the sphere, what we're going to see is it's going to use the second object, so the sphere, as basically the object that we're going to look at to make those connections, which I think is a super cool effect. So that's still plugged into that geo. So what I'm going to do is I'm going to add in a constant. You could add in a line, but I'll just keep it simple. And I'm going to color that pink. And right now, I'm just visualizing my geo 1, so I'll set it to visualize both geos. What we can also do, which I think is a nice effect, is just turn on points, move that point size multiplier up so you actually can see them a little bit better. Something like that is kind of cool. And I might even tweak the line sizes down further. Go up again with the points. There you go, because that affects both. And so what I would do now is, let's go just visualize our Geo1. We'll copy this and say, let's do Geo2. I'm going to comp these together. I guess I didn't delete everything. I'm going to comp these together, and I'm just going to do a simple over. And just to make it a little funky, I'm going to add in a bloom on these lines here. So I'm going to, I'm going to go and just visualize this while I set up that bloom. So let's move the bloom intensity a little bit. Okay, we're going to turn things around. And I think we just want the bloom. And I'm going to turn down this minimum bloom radius, just to make things look a little bit more hazy. There we go. It's kind of looking nice. We'll go back to that comp. And so we can see we have this sort of hazy effect. And you can increase the number of particles that are being sort of visualized with this maximum or minimum difference in terms of this displacement vector. And so this is something that can be like a super fun little effect. I'm going to save this, and I'm going to quickly show you how you can apply this to something that is, any kind of point file. And it will also be a good exercise in showing the point file in action, because there's a new way of looking at point clouds in POPs. You're also going to see how my computer is really struggling here. It's down to 5 gigabytes, so I probably need to delete some stuff, and that's probably why my camera keeps pausing and doing weird stuff. I'm going to bring in a point cloud. This isn't a fancy point cloud like a Gaussian splat. This is just a bog standard regular one. And so what's really great about the new point file in is previously when we were working in tops, we had our point file in and our point file select, because basically we could only hold a certain amount of information in each one of these operators. So we could have the XYZ of the points in our point file in, and then the red, green, blue, whatever in the point file select. So we were kind of limited in how much data we could store in one place. Now, what we can do is we can bring in this point cloud and we can store position, normals, textures, and color. So we can see that we have this little error right now, so we haven't got any normals attached, so I'm just going to delete all of these. And we also don't have color fields in this format. This is a PLY point cloud, so we've got our red, green, and blue, and you can go ahead and just write that in as well. And what we can see here is we still don't have color here, but we do have color, but we just can't see the color. And so rather than having to go into a math, which we had to do previously, because often in point clouds the color space doesn't quite align to TouchDesigners, in this case it's ranging from 0 to 255, where TouchDesigner is looking for 0 to 1. We have this really handy rearrange tab. So rearrange allows us to basically pick a scope or an attribute in the scope. So we could do our point positions or our color. So we want to work with color. And so map from low, map from high, this is basically the input data. So if we say 0 to 255, that's saying we have these color values that are ranged from 0 to 255, and we want to map them from 0 to 1. So now we can kind of see that that has been applied. So that's fantastic. What you could also do is you could add in a second parameter, for example, if you wanted to rearrange something. So I don't actually know what my big and small part of my file is, but let's say I was like -5 to 5, 0 to 1. So you can actually rescale these point clouds really easily. You could also use like an analyze to get that information. I don't want to rescale at this point, but just so you know, you could basically put anything in there and rescale it, which is super cool. So what I'm going to do is first I'm going to save this in case I have a crash. And I'm going to plug this into my field component. Oh yeah, that's brilliant. So now, maybe not the best placing, but what we can see is we have our point cloud being manipulated by this output. And what I'm also going to do is, because I'm now working with a point cloud, I'm going to switch to a point sprite. And what's also very cool is we can see that we don't have to instance any of those colors. It's all kind of been input for us, which is super, super fantastic. So it saves us kind of a lot of time here. I'm going to expand the movement that my point attractor can do, although I guess a lot of it's going to be kind of around me because I'm kind of that central thing there. If I make it really big, maybe I'll get it in some of the walls. But I'm also going to expand the amplitude for this thing. So there we go. Okay. Okay, pretty big. And other things I might do is we have this handy thin tab in our point file in. So we have this option to thin step, which is basically how many points do we jump between. So basically kind of like every 5 points show that point. Or we have thin random, which sort of more randomly takes information out of that space. And so if you have something that's relatively complex, it's not a bad idea to kind of take those things out. Because I'm now also working with, because I'm now also working with a bigger object, I might want to increase or decrease some of that proximity, and I might also want to maybe move up this period so things are moving a little slower. It's the wrong thing to do. Period there. I'm going to turn up my point sprite so I can kind of see a little better. Now I've reduced some of this stuff. And, you know, okay, computer crashed again. Ultimately, if you were doing post-production on this, you would maybe kind of go into this bloom and turn down a few things like that minimum bloom radius, because it's a little too patchy. So obviously there's a lot of post-production stuff you could do here, and that's partly because I have reduced a bunch of the elements here. But really, this is more like an example of how we can actually make these sort of attraction effects. So let's kind of go in here and check out this attraction transition range, and also kind of move our range up. So it's going to be more push and pulley. So it's going to create more radical effects. We can also go into our uniform here, and we could turn up our strength as well, which we haven't played with that much yet. So now we can see as that strength turns up, we're creating this much more sort of aggressive effect. Okay, super fun. So I hope you enjoyed this tutorial, and stay tuned for more. I'll be putting the files up on my Patreon, particularly for that cube, not for the point cloud, but obviously you can go in and put in your own PLY files. And so yeah, hope this has been sort of useful for folks, and I look forward to seeing you next time.